Hello everyone, welcome back to my channel. So today in this video we're going to talk about multi-threading, in which the first thing that we are going to discuss is multitasking versus multi-threading. So what is the basic difference between multitasking and multi-threading? So basically in multitasking what we do is that we perform multiple tasks or processes at the same time, and in multi-threading what we do is we do multiple things within the process. So basically let's understand this through an example. So for example, in multitasking we can have that we are running music on Spotify, we are running something on Google Chrome, and we are writing something on Microsoft Word. And in multi-threading, the examples that we can have is like on the same process. That is, let's say we are on Google Chrome, and in that we are downloading something, we are browsing something, and we'll also have something running in the background in Chrome itself. Like you have a video running on YouTube in a tab of Chrome, you are downloading something and you're searching something as well, so you can hear the audio from YouTube as well. So that's multi-threading, where you're doing a lot of tasks within the process, and multitasking is where you are doing multiple tasks or processes at the same time. Now moving on to the next topic in multi-threading, that is the real world example. So everything that we study, we need to study about what its applications are in the real world. So let's talk about real world examples. So real world examples of multi-threading. Real world examples. So in real world examples what we have is firstly we have word processors. So for example, we're talking about MS Word. So in MS Word you write something, then it also checks for the spellings continuously. Like when you're writing, you get the results of checks itself as well. So that's something that you have in word processors. And then we also have about web servers. So why do web servers need multi-threading? So basically when we are having about web servers, we need fast response for HTTP threads. So for that we use multi-threading. Now next, moving on to a very relatable example for all of us, that would be IDEs. So in modern day IDEs, when we are writing the code, we see that it checks for the compilation errors in the same time. Like you write a code, move to the next line, and it immediately checks, and along with that checking happening, you're also writing the next part of the code. So you're doing both of these things together. So that's an example of multi-threading in IDEs. And then something that is very common these days, that's in games. So in games also you have multiple things going on at the same time. So that's an example of multi-threading too. Now whatever we use, whatever we do, whatever we study, the most important thing about it that we should know is its advantages, so that we could understand when and how to use it. So let's talk about the advantages of multi-threading. So the first advantage of multi-threading would be parallelism and improved performance. So what basically we mean with this point is that when you have a lot of things that you can run at the same time. So that's the basic definition of multi-threading, that we know that we do several things at the same time. So we have parallelism and we have improved performance. For example, if you were to download something and you were to browse something, so now if the computer stopped that, okay, let me download this first and then move on to your browsing, then it would have been a very late process. So it would have taken a lot of time. So that performance is very poor. So, but when you have the downloading happening and the browsing happening at the same time, the performance is improved. So that's what is about parallelism and improved performance. Then the next point about The advantage is responsiveness. So what do we basically demand from anything? That's its responsiveness. So multi-threading gives us a very good responsiveness of anything that's happening or any process. So it improves the responsiveness, as we know that we are having, like, for example, the examples that we talked about, that you're downloading something and you're browsing something. So it's not that the system has stopped responding to you. It's still responding to you by giving you the browsing results while it's still doing something. So the system is responsive and it's not idle. It's not kept idle. So that's responsiveness. Now moving on to the next point, that is better resource utilization. So this is something that's really important. Now, if we wouldn't have had multi-threading, then what we would have had is that the resources would have been idle at some points, and so that means that we're not properly utilizing it, and we're then using extra time to use it. So instead of that, we do multi-threading so that we utilize our resources in a better way. Now we got to know about multi-threading's advantages. Now every coin has two faces, as we know, so let's talk about what are its disadvantages. So in disadvantages, the first point is difficulty and basically difficulty in writing, testing and debugging. So basically when we are writing, testing or debugging our code or anything like for multi-threading I'm talking about, so we face difficulty as into what part should be considered one thread and what shouldn't be, and then there might be cases where we get errors. So we need to be careful about the testing and debugging as well, that when and where, how to use it. So that's a disadvantage of multi-threading. Now the very important one, that is can lead to race conditions and deadlock. So we'll understand this with a better example, what I mean by race condition and deadlock. So when we break things into threads, we basically can face race condition or deadlock as well. So let's understand what it is basically. Firstly, let us see about race condition. So let's say we want to have two threads where we have thread 1 and we have thread 2. What thread 1 says is read x plus plus write x, okay, and this one says after this read x plus plus and write x. Now what happens is that when this process resets x, let's say we have x is equal to 5 given to us. So at this point it would read x, we'll get it x is equal to 5, then we'll add it and we'll get x is equal to 6. Though the system doesn't know this until we write x. So now the system knows that x is 6. Now after we've written, this thread starts reading it. So this thread reads it as x is equal to 6, then it does x plus plus, that is we get x is equal to 7. The system still doesn't know that x is equal to 7 until we write x. After we write x, the system knows that x is equal to 7. Now what if this was done in such a case that the thread 1 and thread 2 were executed like this? Like we have read x plus plus, then we have again read x in thread 2 and x plus plus, and we have here write x, and here also we have write x. Now we can see here that basically this system, what it did is that it broke it here at this point. So now they said that okay, until this we'll have thread 1 running, and then we'll have thread 2 running until these two parts, and then we'll have again thread 1, and then we'll have again thread 2. So this is something that happened here. Now when again for the same case, x is equal to 5, so we had x is equal to 5, the system reads x is equal to 5 and it does x plus plus, that is x is equal to 6, but the system doesn't know that x is equal to 6 until we write x. So the system now takes x as equal to 6 at this stage where it's reading x. It takes x is equal to 5 rather, because x is equal to 6 is not taken by the system until it's written. So it reads x's initial value, that is 5. So it reads 5 and it does x plus plus and gives us x is equal to 6. So here also after write x, we get x is equal to 6, and here also we get x is equal to 6. Which means that we didn't get the desired result, which was x is equal to 7. And this case is known as race condition. Now moving on to the another problem of multi-threading that we just saw, which is deadlock. So what does deadlock mean and why is it happening in multi-threading? Let's see that. So let's say we have two threads, T1, T2, and we have two resources R1, R2. In R1, R2, T1, T2. Now T1 writes R1 and T2 reads R1 and T2 writes R2 and T1 reads R2. What will happen is that T1 can't write R1 until it receives R2. So basically it's not unable to write it, and T2 doesn't write R2 until it reads R1. So that causes a problem because neither T1 will release R1 nor T2 will release R2. So we cannot proceed in this, and this condition is known as a deadlock. That's it for this video. Let's meet in the next one.